Hello everyone, this is Shivaji and I am here to introduce our 6th semester project movie recommendation system. So the introduction is a recommendation system is a type of information filtering system which attempts to predict the preferences of user and make suggestions based on their preferences. For example, if Amazon observes that a large number of customers who buy a latest Apple MacBook also buy a USB-C to USB adapter, they can recommend the adapter to the new user who has just added a MacBook to his cart. In this project, we made movie recommendation system using autoencoders. So the problem statement. The problem statement is to recommend set of movies to a user based on the past ratings given by them on movies.
Well, hey guys, this is Tidesh. Uh, we know everything has its own limitations. So the limitations of autoencoders we are using have one common problem, which is the compression versus conceptualization dilemma. Similar to the exploitation versus exploration dilemma, we want the autoencoder to conceptualize, not compress. That is, learn feature representation. However, instead of that, we reward the perfect reconstruction of the data, which encourages compression rather than the conceptualization. This has caused autoencoders to struggle for more involved tasks. Denoising autoencoders are an attempt to fix this problem by introducing random noise to the input and having the encoder try to remove the noise. Therefore, we represent the feature representation. Therefore, theoretically forcing the autoencoder to learn the feature representation. However, how this works in practice is still not as well as it should be in theory.
Hi, my name is Jamin and I will give you a brief introduction about autoencoders. Autoencoders are unsupervised learning techniques in which we leverage neural networks for the task of representation learning. Specifically, we will design neural network architecture such that we impose a bottleneck in the network which forces compressed knowledge representation of the original input. This process is also called encoding. In the input features, input features were each independent of one another. This compression and subsequent reconstruction would be very difficult task. However, if some sort of structure exists in the data, that is correlation between input features, this structure can be learned and consequently leveraged when forcing the input through the network bottleneck. As shown in image, we can take an unlabeled dataset and frame it as an unsupervised learning problem tasked with outputting X cap a reconstruction of original input X. This network can be trained by minimizing the reconstruction error, uh, which measures the difference between our original input, and the consequent reconstruction.
Hi, my name is Venkat and I will give a brief intro to our code implementation. We have used movie lens dataset for our project. The reason why we choose this dataset is this is from real users and very practical. This dataset is perfect for our project also. We have used PyTorch to create autoencoder model. We have total 5 layers, that is 1 input layer, 3 hidden layers and 1 output layer. In input layer, there are total 1682 nodes which represents all movies in our dataset. In first hidden layer, we have 20 nodes in total. In second hidden layer, we have 10 nodes in total, and in last hidden layer, we have 20 nodes. And this is and for the final layer, we have again 1682 nodes. Now we have taken 200 nodes 200 nodes for epoch. And when it comes to the algorithm, we have used mean square loss as logs function, and we have used RMS prop for optimization. And when come to the results, after training, we have achieved 0.92 as training loss, and after testing, we have achieved 0.94 as testing loss. That's it. Thank you.